Hey, Mr. Richards here. Today's 8th grade Unit 7, Lesson 8, Anchor Problems. And we're going to discover what the converse of the Pythagorean Theorem is today. But before we do that, we're going to look at statements and the converse of the statement, just to make sure we understand what converse truly means. And so examples of statements and their converses are shown below. And I'm not talking about the shoes. The statement, if it is raining outside, then the ground is wet. The converse of the statement would be if the ground is wet, then it is raining outside. Well, let's just look at that in isolation here as we go. Which of these converse statements are true? Well, if it's raining outside and the ground is wet, fine. But does the opposite of that mean it's true? Or the converse, I'm sorry, not opposite, the converse. If the ground is wet, then it's raining outside. Well, what if it stopped raining? Does the ground automatically dry? I don't think so. At least not my yard. It's usually wet for a day. So this is false. If an animal is a cat, it has 4 legs. Hopefully. The converse, if an animal has 4 legs, then it's a cat. I think my dog would disagree. Well, I don't have a dog, but my parents' dog would disagree. So false. If you are between the ages of 13 and 19, then you are a teenager. Fair enough. If you're a teenager, then you are between the ages of 13 and 19. That sounds fair. That is true. If a polygon has 4 right angles and 4 equal sides, then it is a square. If a polygon is a square, then it has 4 right angles and 4 right sides. That is also true. Now, the Pythagorean theorem states, if the triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse, or a squared plus b squared equals c squared. Okay, that is, or what is the converse statement of the Pythagorean theorem? Well, let's turn it around, right? So if we look and highlight different parts here, basically look at the then, and that's going to be the first part of our statement. If the sum of the squares of the legs is equal to the square of the hypotenuse. That's not a y. Hypotenuse. So that covers the second part, right? The sum of the squares of the legs is equal to the square of the hypotenuse. Then a triangle is a right triangle. That's the converse, taking the if and switching it with the then. Do you think the converse of the Pythagorean theorem is true? Well, I don't want to spoil it yet without showing too much of this, but for our purposes right now, I'm going to say yes, it is true. So again, if a triangle is a right triangle, then a squared plus b squared has to equal c squared. Well, if a squared plus b squared equals c squared, then it is a right triangle, is also true. So we can then take that and go, fine, let's use that idea, that converse the Pythagorean theorem, to solve questions, to determine if triangles are indeed right triangles. And so here, let's look. Remember, your C is your hypotenuse. It always has to be your longest side. And so 11 is going to have to be our C here, as it's our longest side of this triangle. Then I'm going to label my A and my B. So in theory, a squared plus b squared would have to equal c squared for this triangle to be a right triangle. So 7 squared plus 9 squared is going to have to equal 11 squared if this were indeed a right triangle. Well, let's find out. 7 squared is 49. 9 squared is 81. 11 squared is 121. Well, unfortunately, when you look at 81 plus 49, now, I don't know if unfortunate is the right word, that's 130. And 130 is not equal to 121, so no, not a right triangle for this one on the left. What about the triangle on the right? Well, let's figure out what the longest side is. It looks like it's the 6, but let's verify this. And if you're given, again, things with square roots or in radical form, you can always see what the radical form of these two other numbers are by looking at what's 5 squared. It's 25. So if 5 squared is 25, then the square root of 25 is equal to 5. Fair enough. 6 squared is equal to 36, and so the square root of 36 is what's equal to 6. Fair enough. Now we have the square root of 11, the square root of 25, and the square root of 36. That must mean that the square root of 36 is the largest side. That has to be a hypotenuse. Now my A and my B with the other two legs. And there's my right angle, if I had one, and that would be C. Let's find out. And actually, I jumped the gun on this one. Let's erase that there and try again. In theory, A squared plus B squared would have to equal C squared. So 5 squared plus the square root of 11 squared would have to equal 6 squared. 5 squared is 25. 11, the square root of 11 squared is 11, and 6 squared is 36. Yes, this is 36. 36 equals 36, so yes, a right triangle is here. And let's go back and say, well, where is that right angle? I kind of ruined it early, sorry. It's right in between the two legs and across from the hypotenuse. Problem 3. The triangle below is not a right triangle. Change the measurement of one of the side lengths to create a right triangle and label the angle in the diagram. Let's see what the longest side is. That's usually the easiest one to fix. And so if I look at 8 squared, that's 64. Why am I doing that? To tell you again that this is equal to the square root of 64. 8 is equal to the square root of 64. 13 squared is 169. And so the square root of 169 is what's equal to C. I'm sorry, the square root of 169 is what's equal to 13. Mine's drifting here, my apologies. And so what that would mean is, it's saying it's not a right triangle, but I want to prove it real quick, that this would be my A, my B, and then my C. Let's just make sure that it's not, all right? So if A squared plus B squared equals C squared, that would be 8 squared plus the square root of 110 squared would have to equal 13 squared. We're going to find out that 64 plus 110, 169. 64 plus 110 is 174. That does not equal 169. So it's not a right triangle, but again, it's telling us to fix this. And I believe that fixing your hypotenuse is your easiest thing here. Why? Well, imagine that you had a right triangle where you had 8, the square root of 110, and you were trying to solve for C. Well, all you would have to do is say, this is my A, this is my B, and say A squared plus B squared would have to equal C squared. Well, that would be 8 squared plus the square root of 110 squared would have to equal C squared. 8 squared is 64. The square root of 110 squared is 110. That would have to equal C squared. The square root of 64 plus 110 is, as we already found out, 174 equals C squared. And the way we're going to solve this, if you have multiplication, the opposite is division. If you have addition, the opposite is subtraction. If you have a number squared, it's not going to be dividing by 2 to undo it. It's going to be to take the square root of both sides. And so when you do that, you actually just end up with the square root of 174 equals C. And that's all we need to write for our answer, is that the square root of 174 is C. So we're going to relabel this as the square root of 174 is the fixed side. And since that's our hypotenuse, then our right angle is going to be here in between A and B, in between our two legs, staring down the hypotenuse. Now that's all the examples that they give us here. But I want to go over just a little bit more with you, just to make sure you know how to solve these kind of questions. And so, if you're given a right triangle, like math magic there, if you're given a right triangle, and you're given the side length, say, of 3, 4, and x, and you're being asked to find the missing side or the value of the missing side. Well, remember, the opposite side of the right angle is your hypotenuse, and your other two sides are going to be your A and your B. And so you can use the Pythagorean theorem, a squared plus b squared equals c squared in order to solve. So 3 squared plus 4 squared is going to equal c squared. 3 squared is 9. 4 squared is 16. I don't know why I was writing 4 there, but 16 equals c squared. 9 plus 16 is 25 equals c squared. And again, we're not going to divide by 2 here to solve it. The opposite of squaring a number is taking the square root of a number. So we're going to take the square root of both sides, and we're lucky here where the square root of 25 is equal to 5. So 5 is equal to c. So that's how to find it if you're looking for a hypotenuse. But what happens if what we're looking for isn't the hypotenuse? If it's one of the legs? Well, let's imagine here a right triangle where you're given, let's say 13, 5, and W, winning W. Well, we follow the same steps, kind of. We're still going to label our hypotenuse, the one across from the right angle, as C, and our other two sides then can just be our A and our B. And so A squared plus B squared is going to equal C squared, and substitute the numbers in the correct spots. W is what our A is here. So W squared plus 5 squared is going to equal 13 squared. Notice it's a little bit different than when you're finding the hypotenuse. When you're finding the hypotenuse, it's kind of straightforward. When you're looking for one of the missing legs, it's a little bit different. All right, so pay attention to what you're looking for on these. W squared plus 25 is going to equal 169. And now solve it like you would most equations. Subtract 25 from both sides here. This is going to cancel out. You're left with W squared equals 144. And like we did in the previous one, once you've got it down to this point, take the square root of both sides. And W is going to equal the square root of 144, which is simply 12. And so you have an example here of what to do when you're looking for the missing hypotenuse. You have an example here what to do if you're given a hypotenuse and a leg, but you're looking for the other leg. And so those two examples are ultimately really important as we continue working here on the Pythagorean theorem. And so you have those two examples. You have how can you create a right triangle? And again, my advice on problems like 3, pick your longest side, call that your hypotenuse, and then redo that one. Redo your hypotenuse. That would be my suggestion. If you're trying to figure out if it's a right triangle or not, we're using that converse idea that a squared plus b squared needs to equal c squared. Remember, c is always your longest side. Sometimes it's not going to equal, the left won't equal the right, so it's not a right triangle then. Sometimes it will equal, and so there it is, a right triangle in the green one. And again, we determined, defined, try to use both words at once, time there, defined, earned. What is the converse of the Pythagorean theorem, and is it true? And yes, it is. And so those are the 8th grade, Unit 7, Lesson 8 anchor problems. Good luck.